Greetings and welcome, friends. Mr. Waddy and my fellow geometricians are here. We were talking about like triangles, I think, and here's the homework. It was about like congruence of triangles. Yeah, all right. I was looking for some nods there. I'm just guessing. I was absent yesterday. Internet friends. Internet mystery. Let's see if you guys can hunt down where I was on October 12th of 2017. There you go. There we go. So let's see. Here it says these two triangles are congruent. Copy and complete the statement. So if these two triangles are congruent, then all of their corresponding parts are going to be congruent. So angles will be congruent to angles, sides will be congruent to sides, and then by def of Cong, all of those measures will also be equal, which is what this is describing here. So measure of angle y is going to be equal to the measure of angle n, which I'm guessing they want me to just say 124 degrees. Did they have the option of measure angle n in the book? No? Well, that would also have been true. Let's see. The measure of angle m is this one here. Which angle will that be congruent to? Yeah, Nick. Angle x. And one of the easiest ways to figure that out is it was the first initial in the name of this one and the first initial in the name of that one. And naming triangles congruent or similar requires that the letters of their vertices line up in the correct order. So yeah, so that was angle x, yep. Which in this case is 33 degrees, like so. And I also could have said measure angle x. Let's see, measure of angle z. Well, I've run out of options. That and that, but what do I do? I don't know either of the measures. Let's see. So measure angle z plus 33. So I could substitute in some of these values and try some theorem. What's that? 157? And then subtract that from both sides. That z is starting to look like a 2. There we go. That's a z right there. Subtract 157 from both sides. Is that 23? All right. I got a yeah, and that's good enough for the internet. So yeah, 23 degrees. I also knew, I knew that these were congruent because they were also already defined as congruent. But later on, we had the third angles theorem, right? Which tells me that if two angles in two separate triangles are congruent to each other, then their third angles will also be congruent. And I'm assuming you guys believe that's true. Did you have to prove it was true? Oh. All right, third angles theorem. So xy is going to be congruent to the segment MN, right? MN, and then by def of Cong, it's going to equal 8. I like it. And that is not in degrees. All right, not bad. All right, so here's two figures. Looks like funny quadrilaterals. And they are congruent by definition. So all of their corresponding parts, both the angles at those vertices and the segments of any two adjacent letters, or the D and the A and the EH and the E, are going to be congruent to each other as well. And so let's see, it looks like this angle and this angle are going to be congruent to each other. So 4y minus 4 equals 28. And I also have this angle here being congruent to this angle there. So 10x plus 65 equals 135. Add 4 to both sides. 4y equals 32. Divide both sides by 4. Y equals 8. And over here, subtract 65 from both sides. 70. Yeah. And divide both sides by 10. Voila. Now, they did only ask me for the values of x and y and not the measures of those angles, so don't fall for that one. Be careful. All right, find the measure of angle 1. So I've got this is congruent to that, that's congruent to that. By third angles theorem, angle C is going to be congruent to the measure of angle 1. By trisum theorem, I can actually find the measure of angle C is 180 minus these, so that's 55. And then by transitive property and some f of Cong thrown in the mix, I'm going to have measure angle 1, also known as R, is equal to 55 degrees. Yeah? Question, comment? I'm not sure which one, or what did it describe? It almost sounds like a congruent supplements theorem thrown in the mix with trisum would kind of show the same thing. I don't know. I'm not sure. Like I said, I wasn't here yesterday, so I'm just kind of making this stuff up. Here we go. They want me to prove these two triangles are congruent. So they want me to prove AEB. By the way, it didn't necessarily have to be the small triangles. It could have been any other. And was it CED? They want me to prove those are congruent. The things I currently know are, bless you, those are congruent. Let me go with green maybe. Yeah, so those sides are congruent, and I know parallelity. I'm going to do a verbal proof here, and it not necessarily same order online homework is in. That sentence wasn't in the same order either. So let's see, I'm going to say this angle A is congruent to that angle C, or EAB is congruent to ECD. Why would that be true? No, almost. That will show up. Alternate interior angles theorem. But yeah, let's go for angle AEB and CED. Those two are vertical angles theorem. I've got this angle B congruent to this angle D by alternate interior angles theorem. One of the facts that I know is that E is the midpoint of AC, so AE is congruent to CE. How? Def of MP, definition of midpoint, and for that same reason, BE is going to be congruent to DE. And then I can prove that these two triangles are congruent. What was the name of that? Like definition of congruent figures or something? I'm tempted to say a theorem that we'll have later on in this chapter, which is corresponding parts of congruent triangles are congruent. Was it was it corresponding parts of congruent figures are congruent? Got it. Aha! I remembered something from 6 months ago. All right. Well, anyways, thanks for watching, Internet friends. Have a great day.